Hello viewers, in this lecture we'll be talking about the capacitor. Now capacitor is topic of class 9's book also as well as class 11's book, but in this lecture I'll be just giving a basic intro of capacitor. First of all, capacitor is a device that is used to store electric current. Like we know that there are thousands of examples like the fan, the devices that we use. Now the electric current when flows from the wires to that, it's a capacitor that is installed in it. That capacitor stores the electric current, and after a maximum part, or we can say that after a maximum value, that capacitor supplies electricity to the like that device that we are using, and it starts moving. Like, have you noticed when then we start the fan, for a while it just take a while to start, or it just take like bit start and then it stops and then it continuously starts. Now that a bit like stoppance is because of capacitor, because capacitor was just storing the like electricity. After that, capacitor consists of two electrical conductors. That conductor plates consist positive and negative charge, positive and negative charges. Now the positive charges moves towards the negative charges, and that is separated by a distance that is denoted by d, and that is one of the most common factor of the capacitance. We'll discuss about the capacitance later, but it is denoted by this symbol. Now this symbol shows us two plates that are connected by the battery, or we can say that that is connected by the source, and there is a distance between that. The space between the conductor may be filled by vacuum as well as insulating materials called dielectric. Now there can be a free space in it, that is known as free permittivity. That there can be a glass between it, so it's called we can say that dielectric. When we are talking about the air, we know that the permittivity then is 1, but if there, just suppose that if there is a glass between that, its permittivity will be 7. So it just gives impact on the capacitance. So there are different types of capacitor as well. We'll talk about that later, but the distance between that is known as dielectric. Now the formula of the capacitor is C is equal to QV. Now here C is for the constant, and that constant is capacitance. Let me just write it here, constant. Constant. Now that is constant, and Q here is denoted by the charge, while the V is for the potential difference. Now here Q is directly proportional to the V. The more the charge will be, the more the potential distance between it will be. Now here the SI unit of capacitor or capacitance is coulomb per volt. Now we know that charge is for coulomb and potential distance is denoted by volt, or we can say that measured by volt. Or we know that coulomb per volt is equal to farad. So 1 farad is equal to 1 coulomb divided by 1 volt is equal to 1 farad, or the value of the farad is equal to 96,500 coulomb per meter. Coulomb per meter. Now here meter is for potential difference. Now that's all about capacitor. Let me just show you a picture of the capacitor. Now by that we can see that you can see that there is a capacitor here. Now as I told you that the capacitor is composed of two electric plates. Now this can be two electric plates, the positive one and the negative one. The positive one moves towards the negative one. Now here these conductive plates are known as we can say that from here to here it's the symbol of it as well, and distance between that is known as dielectric. This is the source of that. And this is the final look. Oh, there is different materials used for that. So there can be different materials that will show the capacitor. And that's all about today's lecture.